Let's see now some improvements that were made in the texture commands and some commands that were also added to it. One of the things that improved, at least in version 8 of Rhinoceros, was the V with one-fold mapping. In version 8 it has a slightly more advanced calculation than in version 7. So this also facilitated some tasks that were a little more difficult before. Some commands were also added, a command to split the mesh so that we don't have to cut it manually through curves. A command to align the surface at its extremities so that when we have some linear pattern it becomes easier to fit on the mesh. A command to make a triangulation of some mesh, correcting some imperfections of the STL. And also a command to convert 3D files and images on a scale of gray. Let's do our first tests here to know a little more about this. Let's create our STL. STL created. Let's start with the mesh division part. Let's use the command separate. This command here works like this. Once we run it, it asks for us to select the edge to create the split. That would be this edge of the STL, choosing one of them. And it will make a path to the end of the border. Here our split will have a distance of 0.01, but we can also increase this according to our need. The length of the extrusion is the distance between one and the other. The longer the extrusion, the greater the distance between the edges. Let's do our first division. Let's take this one that is starting free going up there. Select our edge and it will open the mesh. Let's go from 0.01 to each side. Total of 0.02. Once the mesh is separated, we can use our default command. Click on it and it will plan it open. It has been planned. We can align it now. Rotate. Let's go from one side to the other. It depends on our need. We also have that part of making the alignment. This resource to divide the mesh has made it easier for us to work. In some situations, the STL ends up intersecting. This damages the quality of our texture. We can, for example, align our texture below. When we have a linear pattern. There is another tool of curves that can be useful for us in this situation. Let's extract a curve below. Okay. Let's just change the color here to make it easier to visualize. Right, in Curves tab we can also use this command. To help us in this curve planning, you can gain a certain time. Here we can use the flow along curve to align it. When we align the curve, this happens. If we put a 90-degree curve here, we will see that they are slightly inclined. We can also correct this with this command. Let's continue here. Align surface. We select the command. It will ask for the edge A. We select it. It can be the first or third, whatever. The second. Let's take this second. Now it is asking for the edge B. Let's take the same. We click. It will give me a range. It would be the transition location of the drawing. 100 millimeters is more than enough. Let's give it a OK. What did it do? It took it. Let me erase the old one. It aligned our surface. Look. It will align in this direction. And it will also align the height of it. Let's draw a straight line to the other side. It will be at the same height now. It is already at 90 degrees. It is perpendicular to the plane. And also respecting the same height on both sides. Right? Once this is done, we can take and apply the texture. Look. 3D, 2D. and the texture was applied. This texture here, in this case, is the DX836. A question that many customers ask. How to respect the size. How to know the size that is being given here. There is a technique for this that we will see now. The first thing is to disable the pixel mold. When we disable it, we are working with the image size 1 by 1. Let's cancel here. And we have to check this size. And how is this done? We can import the image of the texture library through the picture plane. Let's go there. It is on the folder 19, DX836. Let's give it a OK. 1 by 1. So what will happen? It will start the image exactly 1 by 1 size. Okay, let's suppose now I want that my space here inside stays with 1 millimeter only. Today it's giving around 16 millimeters maybe. And look, 16.6, okay, but we want it to have 1 millimeter only. So let's go there, 1 by 1. Change color here to make it easier to visualize as our image is white in the background. And let's go there. So what calculation would we do here? Let's divide 1 by 16.6. Okay, so our scale would be 0.060. Just for us to check here, 0.060. Okay, exactly. And it's going to close practically 1 millimeter, a minimum difference. Let's measure here. And 1 millimeter, right? Okay, so this factor that we put here in the image is the factor that we should also put when applying the texture on marking that part of the pixel. Is white. Let's do it again. Okay, we select our image here, okay, which is the image that was imported through the picture frame of the Rhino. Let's put the same value. We find in our calculation. Now let's make a size check. We click here again for the image to appear, and let's cancel here and make a circle. And let's measure it right here until here 1 millimeter. It's the 900th difference. So this is a way that we can use to know the real size that our texture is. Even if we had a printer that prints in photolith, we can print the image size 1 by 1 or with a proportion that we find suitable to make a comparison with some texture that we have to copy, for example. To know if the two are in the same proportion. Let's go now. I'll just finish so I don't lose this step. Here you can work with the precision of a tenth. There's no need to put a smaller value even to leave our file lighter. Let's click OK. Look there, you don't need more than a tenth. I've already copied enough. We have our applied texture, applied and aligned below. Here was our seam. It's going to give a small mismatch, but there's not much to do. At some point we'll have this difference. And let's do some more tests. And if we can erase. And there, and look, for example here. And we have our STL. And I'll make an seam here. In this case I believe that I would make a direct planning. It is planned, but we wanted to align. You would make a cut here. and follow the same path as before. Cut and do that whole work there with the curve. Let's go there. Planning. But both would work. We will pull the same image with the same proportion. And there it's not pulling because I cut it. Let's make this cut, and now it's going to apply the texture. Let's see now another situation if we want to apply a texture starting from a pattern of grayscale, for example. Let's cut it again. We cut. And now we're going to plan. And the planning is done. This is another thing that in the Rhino 8 improved a lot. In the Rhino 7, we would give some auto intersection in this region. So this is already a lot easier to align it. Let's do an alignment that doesn't get well 100%, but there's no problem but to be able to see the command. Look. Let's make a straight line. Okay. Flow. Okay. We can erase. We can erase too. Align the extremities. We take the second edge. Here too. Range to 100. Okay. We can erase the old. Right. What are we going to do now? Let's leave it here. To be able to see. I have some patterns modeled here. What are these patterns? Here, for example. Let's render it in another way to facilitate the visualization. Not that it is necessary. Okay, so this is our pattern. Is a pattern modeled? It is in STL. Right. How can we do to use it in 3D? We can see here. Convert 3D to grayscale image. Select the image. Here is a little broken. Let's take it here. That tolerance is already cool. Right. It is generating the image and it will ask me to save. Let's save it here as test. Okay. Inside the same folder, here is the last image that we worked on. Here is the grayscale pattern. Let's go there. What do we do now? Once it was generated, we can see the image. Select another 3D, 2D. Already searched in the last folder. Here is our pattern. Let's increase here. the visualization of it. My last one. Look. This image was generated from our 3D model. Look. Let's have to change the proportion here. No, it was not exaggerated. It is aligned down. Some places it will appear more and others less. Let's decrease a little, 50%. Okay, it will already appear better. I don't know if this height is ideal. But let's do a test just to see. We will probably have to leave a value a little more tight. But let's try with 1/10 first. Okay. Look, it created. Maybe because of the tolerance it did not give the effect that we needed. It did not look good. I would have to change the tolerance to decrease it. Let's do it again. (2D). The image will already look for the last one used. Let's have to use 0.05. Here too. Right. It will take a little longer to do the calculation. Okay. If the image had a slightly larger proportion, it would not need to use such a tight tolerance. Let's see. Look, it gave a much better result. It gave a much better result. Our rendering is bad. Here is our default. It will be 50% of the default size. As we decreased. Direction also. Let's move. It would be more or less this here. It will not be exactly the same, 100% the same. But it will leave a very close result. Mainly in larger pattern. Let's do another test. We have another default here. Okay. Generating the image. I will save it over the last one. This is the image.